Okay, good afternoon. Does this thing work? Please work. Yes, it works. Look at that. It's the most exciting thing that's going to happen all talk, okay? Because we're talking about boundaries, and boundaries by definition are kind of boring. Where did it go? Really? Wow, that's crazy bad. So anyway, it should say boundaries there, and apparently the light is so bad. So let's get going. I want to tell you some stories, okay? 'Cause stories are good. So there I was in the classroom, and I don't know what I did in my previous life, but in this one I had to teach service-oriented architecture. And so I always started my classes by saying to my students, what do you want to hear? And they invariably would say, how do I find the service boundaries? And I kind of realized that every single programming paradigm seems to be about a hunt for some kind of boundaries. It's another day, and I'm not teaching, I'm consulting. And on this consulting job, it's actually the legal company, which I guess is better than being in an illegal company. And they have about 3 million lines of code, all in a monolith. They have 400 tables in a single database. They have like 4,000 stored procedures in that database too. Probably about 50 tables aren't used anymore, and maybe some hundreds of stored procedures. But it's too scary to change anything. It seems that we kind of need to have some kind of boundaries in systems in order to break them into understandable pieces. Kind of curious that we have complicated and we have complex, and it seems that we have better tools to handle complexity, but not so many to handle complication. I'm on another project. This time it's at a startup in the energy sector. And I go in and I'm like, they have microservices. Finally, some boundaries, a project with boundaries. But then I start working on this, and what happens is I kind of realize that they've got a database library, which is sort of shared amongst all the services. And then when I go and do some changes, I realize I have to do a pull request against the database library, which gets reviewed and merged. And then that has to be released as a private NPM package. Then I have to bump the version of that in some kind of service. And then I sort of do the change. And then I also need a UI change, and that's in a separate repository. So we've done like 3 different pull requests so far. You can't just put boundaries in and sort of expect that everything will go great. Boundaries, they can impose costs if they're not placed in the right location. Jeff mentioned the compiler project I'm involved with. There, I guess we kind of have some boundaries that work quite well for us. We have the virtual machine, which takes bytecode, and it knows all sorts of stuff about, it's for dynamic language. So if you can't analyze the stuff at, compile time and optimize it, you just run the program slow, look at what it does, and then do lots of fancy optimizations based on that. So that's the VM, and then we have a nice compiler abstraction layer, which takes some tree and produces the bytecode, and then we have the compiler front end. And these are managed and run by non-overlapping teams. Some people only work on one, and this all works pretty well. We have really nice, clean interfaces between each of these. But now and then, a change comes up, and it involves having to actually change every single layer. So even when you get the boundaries right, picking which boundaries, it really does say boundaries, just imagine, okay, to have, often involves some trade-offs. Yep. Oh, okay. We can fix it. This is a new one. Hundreds of talks, and then one where some text disappears. Well, they're fixing that, let's talk about the next story. I'm in a meeting, and we're talking about failure. Not this one. There will be another meeting about this. Thank you. Wow. Okay, we're So in this meeting, we're talking about failure, and the failure in question wasn't very funny because it actually resulted in some fairly negative business impacts. And the failure happened actually because one really important part of the system failed, not because anything was wrong with it, but because it was running in a service with something else far less important. But that thing failed, and somebody, probably me, screwed up the error handling, brought the service down, okay? In response to that, we actually moved that out into a separate process, and it survived numerous other system failures. So boundaries can limit the scope of failures that happen in systems. Final story, okay? So on this one, it was a pretty small project, just a few of us involved. And this one was in the insurance sector. It wasn't a very big system. It was like about 4,000 lines of code, and the same number of lines approximately of tests to cover all of that code. And this used the SQLite database. It had maybe maximum 5 concurrent users at the most, but in a lot of cases, it'll be 1 or 2 people using the system at the time. The SQLite database was kind of useful because it had to be deployed in-house, because a lot of these companies were really concerned about data, going off on the cloud and things like that. Anyway, I build the system, and then it gets reviewed. And the reviewer is actually a Swiss guy who bizarrely has a really thick Scottish accent. Well, he says, no, I can't do a Scottish accent. I'm not going to attempt this. He says, if I was building this system, I'd have done a bunch of microservices. Dude, it's like 4,000 lines of code with 5 concurrent users. It has to be deployed in-house. And you want to use microservices? But so much in our industry seems to be about fashion. Things come in and out of fashion. Static linking, dynamic linking. Services, monoliths. Sometimes we come up with cute names like modulifts to try and make us feel better about it. I find that cute, by the way. I really like that. By the way, hi, I'm Jonathan. And yeah, I do stuff. I run the Edgerman Prague office, which means that I drink lots of beer and eat loads of deep fried cheese, because that's a perfectly normal dish in the Czech Republic. I used to teach quite a lot, and then I kind of got tired of being the center of attention and decided I was going to build lots of things instead. So I sort of slot into various teams, and I consult in, and I sort of play architect or team lead or senior developer or guy trying to automate things and then hating every minute of build systems. Yeah, and I had some open source contributions, which Jeff mentioned. So I kind of realized when I was putting this together, first it was kind of odd because it's the first talk I've done in like 2 years or something like that, where there's people in front of me. Thankfully, I'm not very intimidated. I have really bad eyesight and I can't see past the second row. But I also realized when I was doing this, I've been doing software for 30 years. 30 years since I first put finger to keyboard and wrote a line of code. And I've actually been paid for it for like 24 years. It's incredible. I get paid to do this really fun stuff. It's changed a lot in the time I've been doing this, because thinking about what it was like when I started and the sorts of riches we have now with automated build pipelines and CI and unit testing and more modern languages with some sometimes kind of helpful features. It's moved on a lot, but so have the expectations. Nowadays, more users, more data, much greater expectations, much greater distribution. The first systems I built ran on a single machine. I didn't even have an internet connection when I started. Nowadays, everyone wants it to work on their smartphone and all these things. So what I kind of feel like, on average, we've sort of improved the tech, the demands have improved, and it's just as complex as it was 30 years ago. So the more it changes, the more it stays the same. But really, the challenge of managing complexity has kind of always been there. This is a phone number. It's not mine. Actually, I don't know what it is, so don't call it, please. But when we look at a number like this, we kind of say, well, that's kind of hard to remember. But we have this amazing mental trick, okay? We don't say, oh, let's remember every single digit of this. We go chunking. and we break it up into more manageable parts. And so I know that, for example, that 420, that's the Czech country code, so that's not hard to remember. And sometimes they get cute little patterns, like, I once lived at number 22. And in software, we kind of look to do the same. We kind of want to chunk our software systems up into more manageable pieces so that we can sort of develop them and understand maybe kind of what we're doing. But unlike a phone number, the relationships between the chunks in software are pretty involved. I mean, with phone numbers, it's really nice. You just, you dial that, and then that, and then that, and then that, and you're done. Software architecture diagrams do not look this nice. Almost never. And if they do, then they're lying. So what I want to spend the time doing today is looking over various kinds of boundaries that show up in software and talking a little bit about some of their properties. So one of the things I've realized is that boundaries are not so much interesting in terms of what's in and out of them, but they're interesting in terms of what crosses them, because that determines how the small pieces we build interact and fit together. So now if we have a boundary, on the inside, there's a smaller problem to tackle. Maybe there's some properties we can rely on the inside of there. If we're inside a process, then we can rely on, for example, a single clock. If we're inside an object, we might be able to rely on some kind of encapsulation of the state inside of there. And then on the outside, we get an abstraction. We get to talk about not how something works, but what it is, what it does. So in theory, we get some sort of nice, comfortable, chunky thing. So first of all, I want to talk about function boundaries. And by function, I mean, procedure or subroutine, pick your choice. And I thought to illustrate this, let's write some C, okay? C is great fun. And I'm going to use a really complicated C function called local time, okay? No one laughed. Maybe everyone knows what I'm about to do. Okay, so local time is a function that takes what we call an epoch, which is the number of seconds since time began, which is January 1970. Time ends in 2038 when we run out of 32-bit integers. But we take this epoch and we feed it into local time, and it breaks it up into the year, the month, the day, the hour, the second, and so on. So I call this function. I put in the parameter, I get a result, I print it with another function, and sort of predictably, we get out these two different times, and okay, fine. So I say, well, maybe it's a little wasteful that we print it twice. We could call print once. Let's go refactoring. Okay, so we just pull it out and we print the thing twice, which of course is a completely harmless refactor, right? Right? Wrong. So who knows why? Does anyone know why? Okay, no one's going to write C after this, are they? So that's good, by the way. So the reason is that when they invented this function, they were like, well, we don't want to allocate memory, because in C you have to free memory yourself. And it's expensive, so we don't want to make someone free the result. But we want to return it as a pointer, a reference, because otherwise we have to copy. And I think early C compilers were not really very fond of returning structures that you have to copy. Or maybe it's just wasteful. So they came up with an ingenious solution to this. They said, we'll just have a global variable of this type, and when you call local time, we'll update that global variable and we'll return a pointer to it, which of course was a really, really, really good idea. So we have functions, and they have a dear little name, some parameters go in, return value comes out, and this idealized idea of what a function is. But in most programming languages, this is actually a complete lie. Because we also have what I call co-effects, not just me, other people apparently call them this too. And co-effects are things from the environment that you depend on, okay? Things like the current time, or some kind of random number generator. And we also have effects, and this is things that the program does to the world. Input and output, maybe exceptions, maybe mutating state. What's kind of curious is that normally when we see the documentation of a function, the parameters and the return value are right there. Okay, so you see the doc, and it tells, oh, it's like this. That's it. But secretly, if you go and read the description, provided somebody actually documented it, it says, well, it reads this environment variable, and that's how it knows what time zone it's in. And by the way, it mutates this global variable and returns the pointer to it. So this is the effects and co-effects. Now, you can look at this in horror and sort of say, well, can we not do better? And then there's two schools of thought on this. One is that we should do, pure functional programming, because that's the only thing we can be trusted with. The thing is that it hasn't kind of really worked that well. And I think the reason, at a sort of a deep human level, is that we're kind of storytellers. We like to tell stories like this happened, then this happened, and then this happened. We've done this for thousands of years. And that means we sort of keep a current state in our mind as someone tells us a story of where we are. And I think for that reason, I think on average, people are better storytellers than kind of, pure mathematicians. So we also try to find ways to sort of deal with managing state a bit better. For example, object orientation. So here's a dear little object with state nicely, cotton wool encapsulated inside, very cozy. And then, of course, that isn't much use on its own. So we have to have some way across the boundaries, which are methods. And methods, okay, we send in parameters, and we get return values out. All very pretty, except, the object can do co-effects and effects too. Okay, and even worse, what happens if I pass in a reference to a mutable value in a parameter? Then the state inside the object holds a reference to the outside world. What if I return a value from inside of my object that's the mutable thing? Once again, the outside world now holds a reference into the middle of my object, and of course, it's even more effects. This is why, we talk about things like tell, don't ask. Tell an object to do something, don't ask about its state. It's trying to minimize these kinds of cases. So this is what we are told an object is, and then this is what an object actually does when we use it. Quite a difference. So to try and sort of deal with this disappointment, our languages have kind of failed us. Because instead of having some sort of better protections for that, and I appreciate as someone working in language design, it's a hard problem. I'll be fair. But we kind of reach for something we can trust. Process boundaries. Enforced by the operating system. Okay, a nice defended boundary. Processes fail independently. So if one goes down, then the others can still be up. And there's OS enforced memory protection. If we're crossing this boundary and there's some data going, it's copied. There's no referencing going on. And that copying is kind of asynchronous in nature. So we have all sorts of ways of getting processes to talk to each other, files, sockets, all of these protocols like HTTP, lots of ways of serializing things like JSON or XML, protocol buffers. So when we have a communication here, of course, this might take time. So there's a performance cost on this boundary. Also, it might just never arrive because processes fail independently. When you have a monolith and you say, is it working? The answer is yes or no. When you have a distributed system and you say, is it working? The answer is yes and no. In the limit, that's always the answer, because if you're big enough, something is always broken. So when we do a remote procedure call, that is, we say, let's just pretend we're calling a function, but secretly there's a network there. This is double the danger, because you have two boundary crossings with all the risks in every direction. This is why we tend to much prefer sort of eventy things or message-based systems where at least the message only goes in one direction. It's only one way that it can get lost. You have this situation. You send a request. You don't get a response. Did the request get processed? Did it process it and lose the response? Did it never get the request? You can't actually tell very easily. I mean, there's lots of things you can build to make this more reliable. Even reliably delivering a message once only is a really hard problem. Then there's the whole versioning thing as well. So, when you're going to send a message between these two, well, if you want to evolve either side of it, well, fine, but you need to figure out how you're going to organize that migration. Because at some point, and again, at some scale and the limit, you'll always have one version speaking, one system speaking one version of a message, and others understanding another version. That's sort of quite technical boundaries, but there's more. There's boundaries about the people building the software. So there's team boundaries. When I say team, I mean, people basically who we would say work relatively closely together. Okay, so they have their own cadences, their norms, their technologies. They communicate regularly. They plan the work together. They have their own sort of goals, aims, and so on. Maybe some small differences in the team. So when you have two teams, the communication between them is generally slower and more costly. Because they each have their sort of own focus. Focus is something that's really important for working efficiently as a developer, I think. And when we kind of depend on another team, that's fine, but we have to kind of be ready for the fact that sometimes the answer will be, sorry, we're a bit busy. It's going to take a while. So when we structure teams and different teams in an organization, we need to think a little bit about that, because, I mean, if we have a front-end team and a back-end team, you might say, well, that kind of maybe makes sense because they have different skill sets. But generally, they're also building one product, and there'll be an awful lot of dependence here between the two teams. So, the back-end team will build something in the back-end to, some new API endpoint, and then some UI will need building on that. And then, and if you're really lucky, you might get everything perfect the first time, but very often there'll be some communication back and forth there. If that's across a team boundary, that might be a slowdown. So sometimes you sort of inevitably face this. At one of the places I'm consulting at the moment, we have a kind of research team who are very sort of focused on effectively pure calculation. And we have a development team, and their job is kind of to get the data from the real world into the calculations and then get the results out and change the real world. It kind of makes sense to have a team division there. But they sort of plan their work somewhat independently. But we've kind of found ways to try and work effectively together to make those boundary crossings cheap. For example, when I first started, they really just had some very informal, like, okay, we're going to have this function, and it takes kind of these parameters. And I got us adopting a schema language, at which point it was almost more simple, and you could actually write unit tests that their functions return things according to schema, for example, or that we sent stuff according to schema to them. But also we built a bunch of internal APIs, so a lot of requests they came with suddenly became self-service. So we looked at the sort of boundary there and said, how can we make it cheap to cross? Source control is another thing. I mentioned before that, again, this experience with lots of small repositories. So you have this sort of situation where you say, well, I've got to change. I need to do something in the API, and then the front end needs to change in order to use this API. And then you get this awkward situation where one PR gets merged, the other one you get asked to do changes on, and then if you're unlucky, this one that already got merged maybe makes it off to stage or gets deployed. So this boundary crossing between the repositories, again, it's something that can cause some trouble. So you might go for a mono repo, everything together. Sometimes kind of a hybrid thing. This is where we're heading in one of the teams I'm on now, where we have most of what we call the application together, but then a few things are kind of broken off. For example, a library that's sort of versioned and services upgrade to it individually, or deployment tools and things which are kind of managed under a different review process and so on. But the code that changes together is pretty much in one place. The final thing I want to talk about is domain and language boundaries. These ones are kind of interesting because when you work on a complex system, it often crosses multiple problem domains. And these domains have their own language, their own words, their own meanings. And sometimes it's really, really not obvious where one ends and one begins. So here's a sort of recent experience I've had with this. So in the system that I'm working with mostly, at the moment there's an entity called battery. And at some point in history, this isn't an area that we've explored a lot, but somebody sort of heard the word battery and said, well, that means there should be a battery entry in the database. So we have that. But actually, when we started analyzing things, it got really, really interesting. So at some point, the product owner said, we need to figure out the UI, the UX around dealing with batteries. Now, of course, when they actually say that, what I hear is we need to figure out the whole workflow around all of this. So we set up a meeting, we start talking, we discuss. 3 meetings later, we've produced 2 prototypes, and we still are really, really confused. What's really interesting is 2 different sort of perspectives have resulted in 2 prototypes that look really, really similar on the surface. But then whenever we go and start trying to pick out details, one will say, oh, it should be like this. And then the answer is, well, it can't possibly work like that. And then vice versa the other way. And at some point, I kind of had the realization, wait a minute, we're all saying battery. But actually, there's 2 different domains involved here. One of them is trading and one of them is control. And we kind of have this entity that spans the domains. But generally, these sort of domain boundary crossing entities are places where, in a monolith, they're the places where we have the sort of inappropriate couplings, the things that defeat the modularization. In a more service-oriented system, they're the things where we really struggle to find an asynchronous communication pattern that works. So when these come up, we kind of need to try and split them to figure out what's on either side. And when that happens, we start to ask more questions about the role of each of these in its domain. Now, something kind of funny happened when we did this, because we were going through it, and we realized that battery was actually quite a bad name overall. We ended up with market on one side and sell on the other. Then we were in trouble because someone said, wait a minute, but all of our marketing is about the word battery. So then we had to find a sort of way to sort of squeeze the word back into the system somehow. But it's kind of interesting. I've heard quite a few stories like this where, it's like a medical system without a patient entity because it got decomposed across all the services. And this happens surprisingly often. And when you do find these and do decompose them, this is where those nice, clean, asynchronous kinds of communication happen. The ones where, it's not request response. It's more like, well, the control folks publish forecasts every so often, and then we pick up the latest one, and we see what we can do on the market, and then we tell it what we've actually ordered, so it makes a commitment there. So let's finish up. Boundaries show up all over the place, and they're quite different in nature. Some of them we get to choose. That's nice. Some of them are chosen for us, decisions that came before we were involved. Some are implied by the context, and some of them we actually have to work quite actively to discover, especially domain boundaries. Boundaries that work well in one kind of boundary don't always work well as other kinds. This is very anecdotal. I've only worked on some number of microservice systems, but it kind of feels that maybe the style has kind of led to an overconflation, where we sort of have one source repository for something deployed as one process, and then we try and have that as sort of one domain boundary. But the decision to deploy something as a single process is quite independent of the decision of sort of what part of the domain it's in, which need not be the same as where the best place to put source control is. So we need to sort of look at each of them individually. But if anything, I think what I've really observed is, when I first came across object orientation, I thought it was all about finding out what classes I should have and finding out what state would go into each class. But in time, I realized that actually the really interesting thing to start with is the behaviors. It's like I said this morning, it's not the nouns, it's the verbs. In object orientation, the verbs, the methods, are the boundary crossings. But I've kind of noticed this seems to apply across all the boundaries. When we want to really understand the nature of some kind of boundary in our team, in our system, in our architecture, in our domain, looking at how the boundary is crossed, what sorts of crossings happen, how many crossings happen, what are they like? I think I've found that that is where a lot of the real insight and the real understanding of the boundaries that are in our systems come from. So I hope this has been helpful. Thank you very much for listening to me. This is how you can hunt me down if you want to argue with me later. I'll be on the panel also. Yeah, enjoy your coffee.